Hi, and welcome in this new series, the caffeine series. In this first video, we're going to extract caffeine from coffee. So this is what we're going to need. Obviously, coffee. I'm going to use 200 grams. Then we'll need dichloromethane, also called DCM. And then we'll need sodium chloride, which is simply table salt. Sodium chloride is used to exploit the so-called salting out. When it is added to the aqueous solution, it dissolves into ions that occupy the water molecules because they are surrounded by their moisture shell. In practice, water becomes less available to dissolve neutral organic substances such as caffeine. Result, caffeine is less comfortable in the aqueous phase and passes more easily into dichloromethane. This increases the efficiency of the extraction and allows you to use less organic solvent while still obtaining a good yield. First, I opened the coffee bag and weighed about 200 grams. I then took my heating plate and brought 800 milliliters of water to about 80 C. When the water was hot enough, I just had to do a very simple thing: make coffee. I poured the water into the coffee powder. What we're doing here is making a super concentrated coffee. I then let it on the heating plate for 15 minutes to extract as much caffeine as possible. I then had to filter everything. This will result in a very big mess. The filter was keeping getting stuck with the powdered coffee, so I decided to just use a cloth and squeeze it with my hands. The problem was that the coffee was still boiling hot, and I was making a big mess. I was also losing so much coffee, and this completely screwed up my yield. I finally also collected the coffee that was still in the flask. Now that had my super concentrated coffee, besides all the mess I made, I was ready to pass to the next step. I added to the coffee 15 grams of sodium carbonate and stirred. The goal here is to keep unwanted acidic compounds from following the caffeine into the organic layer. Adding sodium carbonate makes the solution basic, so plant acids and tannins react to form ionic salts that dissolve very well in water. Caffeine, instead, remains mostly neutral under these conditions, so it doesn't become ionic and can still move into the organic solvent. This way, the extraction becomes cleaner and the final caffeine is less contaminated by colored plant impurities. Then added 40 grams of table salt sodium chloride. Now that everything was ready, it was time for the actual extraction. I added some coffee to a separatory funnel and 50 milliliters of dichloromethane. I gently shook the separatory funnel to avoid making an emulsion. Then I collected the bottom layer, which contained our caffeine dissolved in dichloromethane. I did the same thing for all the coffee. I then put everything I collected in a smaller separatory funnel because I noticed that a few drops of coffee were still present. I also put some coffee too to aggregate all the remaining drops. After that, I noticed that some dichloromethane fell on my support stand and something strange was happening. The solvent was ripping out the paint from the support stand. Besides that, I proceeded to boil much of the solvent on my heating plate, and I evaporated the rest with a stove. This was now what I had, caffeine crystals. I then added some ethanol to recrystallize the caffeine. I boiled some on my heating plate and transferred it in a smaller beaker. I boiled what was left, and this is the caffeine I obtained. It was 0.51 grams, which represented a yield of 21.25%. I don't know why the yield was so low, but at least it worked. If you enjoyed this video and want to see more chemistry like this, consider leaving a like and subscribing to the channel to not lose the next videos of this series. If you want to leave a comment, it would be very appreciated. Thanks for watching, and I'll see you in the next experiment.